Think engineering is just equations or blueprints? Think again. From mind-blowing tech to game-changing innovations, All Things Engineering by EIT brings you real stories, real people, and real impact. Your front row seat to the future of engineering.
Hi, I'm Steve Mackay, and we've got a discussion here on water security with our esteemed guests, Dr. Tony Turton, who will introduce himself, and Dr. Anna, who will give us their backgrounds as well. I'm an engineer with a focus on industrial automation. In other words, pumping water is obviously something which is of great interest to me. But I'll just pass the microphone to Dr. Tony.
Good day to you. Thank you for having me here. My name is Anthony Turton. I'm not an engineer, but I'm a scientist, an environmental scientist. But more importantly, I specialised in water as a national security risk. So I came to the water scenario out of the intelligence community at the end of the Cold War, and the demise of the South African apartheid state and the birth of our democratic government that brought me ultimately to this part of the world.
Thank you, Tony and Steve, for your introduction. I'm Dr. Evangelista. I'm a civil engineer. I'm also very interested in sustainability in construction and how all those environmental impacts can affect the future generations. So it's a great opportunity to discuss more about the water security in order to ensure that future generations will have proper water to survive.
And I think, Tony, we're obviously going to be focusing on Australia and South Africa. And I suppose perhaps people are always a little bit concerned about one's objective ability with these sort of topics. How would you say that you skilled up to talk about this knowledgeably? I mean, what's your background for the listeners?
Well, one of the current things that I do is I'm an editor for a journal called The Water Policy, which is the official journal of the World Water Council. And I served on the World Water Council as a deputy governor, representing the Council for Scientific and Industrial Research in South Africa. So I came from a national security background into water security. And what was interesting is my introduction to water security happened at the end of the Cold War, when the CIA led a very, very big program to try and reimagine how the post-Cold War world would look. We had these very, very big national security entities that had massive budgets and thousands of highly skilled people, and suddenly the missiles and rockets were no longer relevant. And that was when the first sort of work started happening on environmental security, the flow of refugees, transnational crime, and all of that stuff. And all of that came to a grinding halt when some people flew some airplanes into a building in New York City. And from that moment onwards, everything was reset again. So I sort of come out of that early milieu when the CIA was looking at how the post-Cold War world would look. And I put my hand up and I got involved from the South African Secret Service side. I was a founding member of the Secret Service, and I became the sort of go-to guy for water as a national security risk.
And how would we're obviously going to be talking about Australia as well as South Africa. What's your background for Australia? Because obviously that's where we're based at the moment, in dry Perth. What's your antecedents for Australia?
Yes, I was first brought out to Australia after Cape Town had its day zero crisis. I was the media spokesperson for the CSIR in South Africa for water. And the BBC did an interview with me in an empty swimming pool in Newlands, Cape Town, in about 2017, 2018, I think it was. And being BBC, that was broadcast all over the world. And within a few days of the broadcast, I was contacted by British Columbia, I was contacted by people in New Zealand, and I was contacted by the chairman of Vic Water. And he invited me to participate in a strategic planning session for the city of Melbourne, so that they could learn the lessons from the Cape Town Day Zero crisis. And that was one of my first exposures. And then I had another subsequent exposure up through the seas, through Cairo, up in the Burdekin, the Shire of Burdekin, up in northern Queensland. Also, they've got serious water-related issues there. So that has been my exposure, and I've just come back from a massive 12,000 kilometre cross-country trip where I went through, amongst other things, the Murray-Darling Basin, and I looked at various parts of the national security framework for Australia. The things like the Snowy River project, and of course how the energy is now becoming linked into that. So there's massive civil engineering programs that are coming out of these reassessments. But my interest is on the upstream side of those things. The decision-making process at government that triggers those eventual very, very big engineering projects.
Tony, can I just ask you something about the variability in terms of the rainfall data here in Australia? Do you think nowadays we have clear data on the rainfalls, and then you can consider this in our projects?
I think data is never ever sufficient. There's never enough data, and it's never reliable enough. When I did my doctorate, and a part of my doctoral work was I came from an intelligence environment, and we had the classic problem in the intelligence world: you never have enough data. And you've got to make decisions against a background of extreme risk with imperfect information, often from conflicting and untrustworthy sources. So how do you make a decision in that milieu? And I think that is pretty true of a lot of things. However, you will find in places like Murray-Darling Basin, there will be a huge amount of data in those sort of places. So there are data-rich environments. But we're going into a world now where data is going to drive everything. And I'm a firm believer in artificial intelligence and big data. Absolutely, I'm completely I'm upfront in that sort of thing. And I sat on the board of directors of a company that is involved in the development of AI. So I'm completely in that space.
Yeah, that's great.
So I suppose AI is obviously the topic which everyone talks about as being the great hope for the world. How do you actually believe AI can be of assistance in looking at data, Tony? I mean, there's a lot of hype, as you know, and I'm sure over the next 12 months we're going to have a few disappointments, perhaps not. But how do you think AI can actually help with the examination of data and sort of showing that it's reliable, useful?
Yeah, I think AI has got many, many dimensions to it, and we can't do justice to it here fully in this conversation now. But my understanding of AI is the following. Firstly, there's a huge amount of data out there, and some of it is just readily available, but it has to be looked for. So I see a role, for example, I was involved with the Swedish Foreign Ministry as a part of a project where they asked us to develop a national security program that we call the Interseed model. Interseed was the international security, energy and economic development. And we started looking at open source data, which is readily available, but how do you troll that? How do you find that and pick it up in real time? And then how do you process it? How do you actually make decisions on it? And how do you start developing trends? And then I've got further than that now. I've gone down into systems level. So, for example, I've done a lot of work in the sugar industry, where we've gone down to actual process control within a sugar mill. And that is, we've taken that upstream. For example, we can start looking at prediction of the quality of sugar that's going to come down into the mill 3 weeks from now, 4 weeks from now, a month from now. And we can start actually anticipating what some of the engineering problems are going to be. For example, the buildup of scale in your evaporators and stuff like that, and you can start predicting that. And so this, I think, is where we're going to start going. The problem is that there's so much data, and there's the reliability of that data. This is a big issue. And I think the other important thing is that I'm seeing emerge, without any question of doubt now, is the digitization of the total water value chain. And Australia is doing a very good job in that. There's some Australian technologies that are now entering the global market because Australia's got water rights, and the water rights are tradable. Those tradable water rights can now be followed with blockchain and turned into fungible assets. And they've now touched down in Cape Town, in South Africa, and they're starting to expand there as well. So I think this is something that's certainly going to become very, very exciting for the future. And I think the big thing that's going to start coming out of this, which is we're not there yet, and that is that as we start developing reliable streams of data that are trustworthy and robust and that can't be fiddled with, we can start developing the concept of tradable water credits. And those can then be traded on like a stock exchange.
So similar to the carbon credits?
Similar, but they're a little bit more fuzzy. Something similar to that, but let's call it a derivative of that. A lot of work needs to be done, and I'm working with a guy that wants to do his PhD on that particular topic. But nonetheless, this is, I think, where we're going.
So, Tony, I mean, just to take a back step, when you look at Australia and South Africa in terms of the water, national security, and obviously water security as a part of national security, where do you think the big challenges are Australia compared with South Africa? What are the major challenges in a few points?
Well, I think the challenges are similar, but there's also some important differences. So I'm a relatively new kid to the block here in Australia, so I don't want to speak with great authority on Australia. But having just been across 12,000 kilometres across the country, I think I've seen quite a lot there. So what I would say is the following. I think the similarity between the two countries is the following. They're both big bits of real estate, although Australia is vastly bigger than South Africa. They're both very arid. They've both got very high evaporative losses. But where they've got water that's generally quite reliable. So the southeastern part of Australia and the east coast have got huge amounts of water there. In fact, I was quite shocked when I saw up at Brisbane, the entire suburbs that are built on water courses, engineered water courses. So the difference now is that what do you do? Firstly, how do you convert that water resource, a unit of water, into a unit of value down the line? Now we get into the virtual water conversations that we had offline, etc. What is the best use of that water? And there's something very interesting coming out of the Murray-Darling Basin at the moment now, and that is that with the wine industry that Australia is growing, one of the problems now is the conversion of a unit of water into a unit of value through wine is compounded by the fact that the price of water, because it's traded, the price of water is quite high, and the product that's produced is what they call box wine. It's generally low quality wine that's mass market available, a type of wine. So now there's an interesting lesson that can be learned from South Africa that can teach the Australian wine industry something about that. But the important thing is, in the future, let's define the problem. We're going to see a world that is changing rapidly, and change means lots of things, but we're going to see a world that is becoming more variable. And more importantly, our finite water resources are going to start reaching or hitting the absolute constraints of human population.
And food security as well.
Yeah, so then from that ball of wax, we start getting national energy security, national water security, national food security, and collectively that becomes part of the national security conversation. But having said that, what makes Australia different to South Africa is Australia is very innovative, and the government is generally quite credible, and they're quite fast moving. So they tend not to be overly constrained like they are in South Africa. They tend not to be overly dogmatic. So, for example, they tend to be quite responsive to the needs of the future. And I think more importantly, the population dynamic in Australia, it differs fundamentally to South Africa. Population growth here is not as fast, not as rampant, it's more controlled. And where your population exists in Australia, it's mostly in the cities and mostly on the coastal areas. So water provision is fundamentally different under those circumstances to South Africa, where, for example, Johannesburg is running out of water, but you can't desalinate in Johannesburg because you can't dispose of the brine. So the brine disposal becomes a fundamental, absolute show-stopping kind of problem. And of course, now that results in a whole lot of other issues downstream. But that's just by way of introduction.
Why can't you dispose of the brine, Tony? That's quite interesting, because I always believe recycling of water, I mean, it's not very palatable, as we know, but recycling of water, I always remember as a kid in Walvis Bay in Namibia, where they recycled water in the early 60s. Why can't they recycle water in Johannesburg, for example? I mean, but you saying the brine is a big problem. You can't pump it underground into a mine or something.
Yeah, okay, so there are two questions that you've asked me there. So the first thing is Windhoek. The city of Windhoek, for example, is one of the oldest cities in the world that's running on a direct reuse model. They take sewage, treat it to potable standard, and directly reuse it. Perth indirectly reuses it. You know, they take sewage, Beanie Up Wastewater Works, they pump it down into the Leederville aquifer. They capture it, they store it, and they pump it out 20 years from now. So that's fundamentally different. The problem now with brine, the problem with desalination is that the salt that's in the water, or the minerals that are in the water, you have to take out and you have to dispose of those. Now, where we found that problem as an acute problem was in the goldfields of South Africa and the coal fields of South Africa, which are up in the hinterland of the country, and there were two developments that are taking place there. The one is the goldfields, which sort of ran out of useful life in about 2002, and there's a massive acid mine drainage problem, decanting water, which you don't get in Australia. I'm not yet aware of that kind of problem in Australia. Now the idea was that they should desalinate that water. And then the question now arose, what do you do with the brine? How do you dispose of the brine? Because the brine, in that context, you've got sort of 3,000 parts per million sulfur, so you've got very, very high levels of salinity, and you end up the available sort of ratios are roughly 60-40. So you sort of 100 units that you put through, 60 comes out as product, 40 comes out as brine, something in that order of magnitude. So that means you've got to have a brine disposal facility like a tailings disposal facility that will grow infinitely over time. And because brine is hydrophilic, it attracts water. It's not hydrophobic, it's hydrophilic. It attracts water, so it never dries up. So therefore you end up with a great big dam of jelly, and imagine a kid, or imagine a donkey or a horse or something walking over this jelly-like substance and just disappearing. So the disposal of brine is a problem, and now, sorry, it's a long-winded answer, but that was taken to the next level by Anglo-Thermal Coal. Along with BHP Billiton, they launched the project in the coal fields, and that project was interesting because they said they want to now start desalinating to the point where they can recover 98% of the water and only have 2% brine, so highly concentrated brine. And that led to a very, very innovative program that was led by University of Cape Town. A colleague of mine was actually one of the engineers involved in that. I still work with him today. And they came up with a thing called the eutectic freeze crystallization process, where they froze the brine, and then by freezing the brine at certain temperatures, you get the precipitation of very, very precise chemical compounds. And so that is the future. But now the problem is that the chemical compound you get is mostly gypsum, and there's tons and tons of gypsum available. It generally has got very low economic value. But that has now been taken to another level for example, in Saudi Arabia, where the Saudis are saying that we must stop thinking about desalinating seawater to sell it for drinking purposes, where people don't want to pay. It's got no economic value. And we now got a problem with disposing the brine, and they're saying we must rather think about concentrating the brine. How do we concentrate the brine and use that as to mine? So this is sort of an intellectual thought idea where we're going in that direction, but ultimately it comes down to the fact that, just to summarize it, in South Africa, because the population is mostly far from the ocean, you can't dump the brine anywhere. You've got to dump it in a place where it grows and grows, whereas in Australia, you just simply put it back in the ocean. It gets diluted out and it becomes statistically quite insignificant. It's a lot easier to manage in Australia than it is in South Africa.
So, Tony, with Windhoek, the brine there, that's quite far inland in Namibia. How do they deal? Because they've obviously, is that a long-term problem, do you think?
Well, the Windhoek, firstly, they don't desalinate there. They use biological treatment processes. It's just a treatment of sewage. They're not actually extracting salt. They're not desalinating it. So it's only when you desalinate that you get this concentration of brine. That's my understanding of things. So it's a fundamentally different process. In the case of Beanie Up, they've got a biological process, but they then put it through RO, and that's where they get concentrated brine, and then they dump that brine out in Mullaloo, the pipeline that goes out to Mullaloo.
Sure. Oh, that's quite clever. I never realised that significance. So, just to obviously take a step back, obviously Anna and myself are engineers, and you mentioned at the beginning of the conversation, mate, it's all about we do the political planning, and then the engineers get the instructions of what to do. So what are the instructions that you would give the Australian engineers to obviously address these problems as opposed to the instructions you give the South African engineering community? What are the two different sets of instructions to deal with the water shortage?
I think Australia has done a pretty good job, in my view, of water resource management in general, and I think certainly of economic development in an environment that is quite harsh but also quite fertile in certain places. So it's not for me to sort of to tell Australia what they should do better, but I think what we do know is the world is changing. And what we did yesterday is not necessarily going to inform what we can do tomorrow. So the question now, and this is why I'm interested in EIT, is how can we develop the brains and the mindset for the future? How can we think about things differently? So I think where Australia is going now is, if we can define the problem, the fundamental problem is that the economy in Australia is essentially a minerals-based economy with some agriculture. So it's about mining. It's an extractive economy. It's not a manufacturing and processing economy. So how do you get those vast minerals out of the ground without causing massive environmental impacts on the one hand, and dealing with the social and political sensitivities of the Aboriginal First Nation people? That's a political issue of great sensitivity. But in that mix, there's a technology platform, and the question now is how do we start going in that direction? So I think Australia is doing it pretty well, and I think the reason is that the Australian government is quite responsive to the needs of society, and because they're not, from what I can see, they don't appear to be overtly ideologically driven. They're not they're not in a dogmatic paradigm. They're quite willing to shift, based on inputs from society.
That's really great to know, but one of my concerns is when you think about globally, and the population is growing.
Yeah.
When you think about China, India, and other countries with huge population, in order to secure that these countries can grow and still we can observe the United Nations Sustainable Development Goals. My point is, normally we discuss a lot about carbon emissions, but this is my humble opinion. I think we need to get more discussion on the topic of water security and scarcity. Do you have this similar perception?
Yeah, I think, okay, so the problems are there. They're real problems, and these are very genuine problems, and engineers are problem solvers, so let's stick to that. However, there's discourses that come out of that, and these discourses get politicized. And unfortunately, the carbon discourse has become quite politicized, and the alternative energy, the renewable energy discourse has become highly politicized, etc. And the climate change discourse has become politicized. So we're living in a world, a post-truth world, where even as trained, skilled people, we battle to sometimes know what we're looking at. Is it true or is it not? Is this data actually valid or not? So what about the average person out there? They're just overwhelmed by it. So the problems are there, and I think what I'm trying to say is that these problems will always be politicized, and our role is to try and cut through that politicization process and stick to the facts. We've got to stick to the facts of the matter and understand the vector in which, or the trajectory in which society will be going, and then those new risks, those new opportunities, because with every risk, there's also a lot of new opportunities. So, and a classic example would be now, for example, in Australia, this incredible development that's taken place in the Murray-Darling Basin that has brought about amazing industrialized agriculture on a world-class scale, but it's going to have to change at some time in the future. You can't carry on doing what you've always done, because now we get to the interesting thing, and from an AI perspective, the unintended consequences of what we've been doing. How do we resolve those unintended consequences? And that is where my skill set would sort of start coming into the team, because an engineer very often can't always think about those things. Their mind isn't free floating. They tend to be quite structured people. From an intelligence risk perspective, we look at it from a risk landscape perspective. So we come to the same conclusion, but through a different pathway. And I think that's the important thing: is how do we build new teams? Because the teams in the past, for example, they were tended to be dominated by engineers, And then over time, as environmental issues started becoming more of a concern, you now started getting environmental scientists coming in. And then as political and social issues started becoming more of a concern, you now had to start bringing in social anthropologists and legal pluralists and stuff like that. So the complexity of your team has changed over time. And now we've got another layer of that, national security. What about the post-Donald Trump world, for example? What does that mean for Australia? The new world order that's coming out. What are the implications of that for all of the production that's taking place in Australia? And ultimately, it comes down to a set of policy choices. How do we make these? How do we put the information on the table that the policy maker knows what is the best policy? How do we depoliticize that? Because the political process just adds noise. How do we put the facts on the table? And then how do we ultimately make the best decision that's in the collective best interest of society? And that's really where I think, that's where I like to position myself, in that space. Just to workshop the ideas, to sort of brainstorm the ideas. And, I'll just say one more thing. Problems are good things, because a problem by definition can be solved. A dilemma is a bad thing, because a dilemma by definition is something for which each possible solution is equally unattractive. So our role is to convert dilemmas into problems, because problems are soluble.
Are you looking to level up your engineering career? EIT offers industry-led courses, many are internationally recognised, online or on campus in Australia, giving you the practical skills employers value. Tap the link below to explore our courses today.
So, Tony, with to take that one step further, to look at a factual situation, you just come back from the Murray-Darling Basin, and obviously you're obviously aware of the lack of water there a few years ago, and the river ran dry, and obviously all the stresses. What are the facts for the Murray-Darling that you see for water? What are the facts, and how do you see the long-term trajectory to deal with the facts, the issues that have come up there? So what are the facts of the Murray-Darling? As you've suggested, it's not a long-term proposition the way it is at the moment.
Yeah.
So what are the facts, and how do we see things going in the future?
Okay, so what I noticed, I'll just give you first-hand sort of reconnaissance report now. So when I was in Canberra, I noticed this incredible little city in a very desolate place, but with lots of waterways also. Lots of water, and a jet of water like you see in Geneva, a jet d'eau, same sort of thing. And then later on, I went further downstream, and I intersected that same river, but further down in the basin. And there it was putrid, it was smelly, it was clearly becoming eutrophic, and it was you can see the unintended consequences. That water has been through a human kidney a few times, and it's also been through the ground a couple of times, so it's becoming degraded. So water quality degradation, eutrophication, is probably one of the biggest emerging risk factors that engineering is going to have to deal with. Okay, so that's just one of those things. The other thing now that I also noticed in my journey, I'm a wetland guy. I like wetlands, and I like engineering solutions in partnership with nature. That's kind of my quirk, And I was driving down the road, minding my own business. The next thing I saw an engineered wetland. And you see engineered wetlands there. Now, this is something of great significance, because in India, for example, in Calcutta, East Calcutta, there's got a massive engineered wetland system. So I think this is something from an engineering perspective where we're going to start seeing all kinds of things going in the future. So we get back to your question. We're going to have to adapt, and we're going to have to do things differently. And once you start thinking of different things, you've actually opened up a potentially infinite number of options. So what is the best choice for those options? Where, in terms of cost-benefit analysis, what is the upside, what is the downside? But the important thing is change is coming. You cannot carry on doing what you've done the same way. And I'm optimistic, I'm an optimistic person by nature. CSIRO is a great organization. CSIRO is deeply embedded. They in developing all kinds of solutions and whatever. But you asked the question earlier on about, is it smart to grow cotton in these vast arid areas using your otherwise scarce scarce resource? Well, that is a complicated question to answer, because there'll be massive vested interest in that. It'll be a highly politicized conversation, but ultimately it's a conversation that one has to ask. And in fact, I will answer that by saying Israel had to answer that question, because they had to ask the question: is it the best thing for them to do on their kibbutz to convert a unit of water into an orange, and then sell that orange to Europe? And then they decided to rather crush the orange and sell the juice, concentrated juice, and then let the customer put the water in. And I see that a lot of our orange juice in this country is probably comes from that route.
So, Tony, you mentioned, which is obviously very interesting from an engineering point of view, what's an engineered wetland? Is it obviously they're just pumping water into an area? What's the benefits of an engineered wetland?
Yeah, okay, that's a lovely question. Thank you. So wetlands have evolved over geological timescales, and they've evolved in a very precise area. They've evolved in an area where the ground is saturated sometimes and it's not saturated other times. So they can live with wet feet, for want of a better word. And therefore, morphologically, some of the wetland plants have actually changed. Their morphology is different to an ordinary terrestrial plant, and they've got the capacity to live in anoxic environments. So they can live in an area where there is an oxygen-deprived environment. So as a result of that, they've got the capacity to pump oxygen down into a tiny, let's think of a membrane that exists around their roots, called the rhizosphere. And that rhizosphere, it's a fraction of it's a few microns in thickness, but it's very vast in area. And that is an oxygen-rich environment in an otherwise oxygen-deprived environment. And it's in that space that you start getting all kinds of bacterial activity, all kinds of metabolic activity taking place. So now the question is, how do we use that to our advantage? Now, if you look at any wetland in the world, I did a lot of work on the Okavango. I've written a book about the Okavango. I've worked on the Nile, so I'm very familiar with the Nile, Delta, etc. I'm very familiar with the Mekong. I've worked in the Mekong. All of those have got the same problem when it comes to a wetland. Water, hydraulically, tends to find a preferential flow path. So every single wetland will end up typically with about 5 to 7 distributaries. So you end up with a delta and 5 to 7. That's it. I don't know why the number is that, but that's what the number is. Okay, and as a result of that, your preferential flow path dictates that probably 95% of all of the roots in that area are unable to do what they can do. So I took out a patent on this little problem, and I solved this little problem, and I converted a wetland into a spreadsheet, and every cell in the spreadsheet now, I can create isotropic flow conditions. So I can create identical flow in every cell, and therefore I can optimize, I can get every plant in that square meter to do the same amount of work, and we can scale that up infinitely like a Lego block. So that's my understanding of this. And I think this is something that in the future we're going to see more of it, because we can either engineer a process using heat and all these kind of heavy engineering things, or we can engineer in partnership with nature. And if we look at the big problems coming up, for example, endocrine disruption, the metabolization of medication in our return flows, pesticide use. I'm shocked at how much pesticide is used in Australia. All of this stuff is coming back in our water, and ultimately we're either going to have to define an individual set of processes for every one of those infinite number of things, or we're going to have to reach out to nature and hope that nature is also adapting through its natural processes and is capable of metabolizing these things. Think of the PFAS, the PFAS problem that's coming out now. It's a major problem. So these are problems for the future, and it comes down to a fundamental philosophical question. So philosophy is a lovely thing for engineering, and the philosophy of engineering, as I understand, is all based on René Descartes. That's my favorite French guy. I think, therefore I am. And René Descartes, he said, I saw things of great interest. I saw fire and wind and this, and I saw that we can become masters and owners of nature. So engineers are masters and owners of nature, and therefore, are we above that? Are we above nature? Are we Homo sapiens, the wise person that can really understand this thing and take on that role in a responsible way, or are we always going to be victims? And I tend to believe in the Enlightenment. I tend to believe we can solve these problems, and therefore, I tend to work in that direction.
I think for us, when we think about education and engineering, more and more we need to find the balance, because we need water, right? But we also need to ensure the quality of water. I think this is the risk. I think we need to think about the scarcity of water, but how we're gonna also be able to ensure the water is potable, and how we can educate not only the engineers, but the future generations in this sense.
Can I just tell you a little story? I don't want to digress now, but I found myself at part of my career in the hallowed halls of the Royal Swedish Academy of Science. A colleague of mine, Professor Malin Falkenmark, was being given her Lifetime Achievement Award. She's a Swedish woman. She was the Swedish woman that she asked a fundamental question, which is part of this national water security debate. So she was very instrumental in my thinking when I did my PhD, and I was invited to the Royal Swedish Academy of Sciences to celebrate her lifetime achievements. And when I was in that great hall with Linnaeus, a painting of Linnaeus on the wall, looking down at me, and I felt all very, very important. And I had to give a talk, and I gave a talk to these really top range scientists. And I felt emboldened, and I asked the question. I said, I'm looking at some of the best brains in the world. I'm going to make a statement now. Please tell me if I'm wrong. And I just went for broke, and I said, water is a flux that moves in time, in space, but we manage it as a stock. That is our fundamental problem. Water is a flux that moves in time and space. The volume of water we have on planet Earth today is the same as we had when the dinosaurs ran free. We've not created more water, but we're just damaging it. So if we think about water as a flux that is a continuously, infinitely renewable resource, that's a mindset change that's then going to result in engineering changes. So I looked at the audience, I fired my cannon, and they either going to fire back and tell me I'm nuts, and not one person said a thing. They didn't take me on at all. So I'm convinced that water is a flux that moves in time and space. Therefore, it's infinitely renewable, and therefore the only limitation is our own ingenuity. And that's why it's exciting to be at a place like this now, because when we start talking about what are the limits of ingenuity, where can we go? How do we develop new programs to train people to think differently? This is what really, really excites me in the mature part of my life.
So, Tony, what would you suggest, in terms of education and training for engineers and technologists and technicians out there? What sort of stuff do they need to know about or learn about when it comes to water and security?
I think the answer to that is not such an easy one to give, but in sort of simple terms, we have to give hope, because where there's no hope, then people get very desperate. Every problem is soluble by definition, so that's what we've got to do. So we've got to start engaging in conversations. We've got to open up the conversation on things. And in fact, let me just answer it with another observation of mine. I grew up at a time, I'm in the same age group as you. I grew up at a time that our thinking was driven by reductionist physics. The whole thing about reductionism. You can reduce a complex world into a set of very fundamental principles, and you can have an independent variable, and you understand that, and that's how the world works. And I always felt uncomfortable with that. And when I was at this Royal Swedish Academy of Sciences, that's when I realized that I had an aha moment. You see, we're not living in a reductionist world anymore. We've reached the limit of our reductionist thinking. We've now got to start integrating, because with a product of our reductionism is we've now created such levels of specialization that we no longer have transdisciplinarians. Some people don't even know how to spell the word transdisciplinarian or transdisciplinarity. And that's what we need. We need to have transdisciplinary thinking, and how do we inculcate that now in an institution like this? That's another technical conversation, but I think it can be done and it should be done. And I think we start off with this kind of conversation, hopefully just exciting people, getting people interested in this, taking it wherever it's going to go, but ultimately giving hope to people that these problems are in fact soluble.
Well, I certainly think AI is driving a transdisciplinary approach. You have to know the world today, and you have to be critical thinking across the whole range. So if you're going to drill down into speciality, you're going to have some difficulties in the future. So certainly AI is making a huge change to the way we think. And you've got access to lots of information from different areas. So, it's definitely an interesting concept, Tony. So I suppose, obviously time is
running out.
So let's just summarise we've spoken about Australia and South Africa to a large extent, but as far as the whole world is concerned in terms of water security, what do you think are the top 3 or 4 issues and facts that we need to deal with there?
I think, so water security, as I understand it, is the capacity of an economy to do what it thinks it needs to do within the constraints of its finite availability of water. So think about it as that, okay? So in engineering terms, we talk about assurance of supply. You want to have a high assurance of supply, but you've got to plan ahead, and that's what Australia does very well. They plan ahead, they think in the future, and so we've got to start thinking now about those different scenarios going forward. It's an exciting conversation. It's an exciting journey, and I look forward to taking it. So, but what it comes down to is the following: what we're seeing happening now is, firstly, we're seeing a great increase in our population globally. This is a global phenomenon. Yeah. Secondly, we're seeing migration of people into areas of great fertility, the floodplains, where they're very fertile, and this is where people are settling. In Australia, 90% of the people live in the floodplain around the edge of the continent. So this is an issue. Then, of course, we're seeing the unintended consequences of pushing rivers around for a century. So we're seeing the unintended consequence now of an impairment to stream flow reduction and sluggish rivers. We're seeing that in the Murray-Darling Basin, for example. And then the big thing now is eutrophication. So the enrichment of water, it's complex. It's not only about having more elements, more nutrients in the water. It's also about changing temperatures, changing pHs, coral bleaching and all that kind of stuff. So that's a big issue. And I think the other big issue now is the endocrine disruption, the water quality that comes from the persistent use of a century of medication. The unintended consequences of that now. That's going to increasingly become a finite constraint. So that's pretty much what I see it. And I think in a mining economy, the big thing there now is how do you carry on mining, because mining is clearly a part of the future of the planet. How do you do that in a responsible way that causes the least possible impact without just greenwashing? How do you do it in a sustainable way? And how do you limit the impact? And it's hard to dig a hole in the ground and not have an impact. But you can do it. I believe fundamentally, I believe in enlightenment. We can be enlightened about these things, and we can limit our impact, and we can do things responsibly. So this is pretty much what I think of as, is the future, and it's all going to come down to rethinking processes, rethinking logic, and if we can't measure something, we can't manage it. So how do we start, for example, quantifying the virtual water flows? The potential cost-benefit analysis of a virtual water flow versus something else, and this is, I think, where we're going to start going in the future, in the quantifiable, finite way.
Brilliant. Well, thanks very much, Tony. I suppose Anna, you have any final comments to make? I think Tony's taken us from Australia, South Africa, all the way to various other countries, and then the world, and we've got a pretty good view on what needs to be done. And Anna, do you have any final comments?
No, first of all, thank you very much to share with us your knowledge and expertise in this sense. And because I truly believe it's all connected, right?
Yeah.
If you think about water security, it goes to national security, then it goes to economic stability, and it ends up on global peace.
Yeah.
Because this is the main problem the humanity is facing now, right?
Yeah.
And the water is one of the key points that if you don't have water,
Yeah.
what else you can do?
Yeah.
So thank you very much for sharing all the options that we just need to keep in mind as engineers, as human beings as well, because this is something that you need to take care. Otherwise, the future can be very difficult for everyone.
Yeah. Yep.
Absolutely. Thanks, Anna. Certainly, I always used to think energy is the most important issue, and being an engineer, electrical engineer. But when Perth started running out of water and then started building desalination plants, and then I looked at all the consequences there, I thought, ooh, and of course the energy requirements there. And then in Cape Town with zero water, everything drying out, I thought, ooh, and then obviously in Johannesburg, no water at all for weeks on end. I thought this is horrific. And of course I know then, and I know now, that water is far more important than anything else, and we ignore it at our peril. So we've got a lot of follow-up sessions to this, which Dr. Tony Turton is going to run and present to go into some of these topics in a lot more detail. So thanks very much, Tony, for coming along and holding forth. Your passion for water is unbelievable. And you always say, no, I'm not an engineer, mate, but your knowledge of engineering is second to none. So very grateful for you and drilling down further over the next few sessions.
That's a wrap for today's episode. Follow all things engineering and click the link in the description for more insights, tips, and course information.